Welcome back, algebra fans. This is the last lesson we are doing this year in Chapter 9, Solving Quadratic Equations. So we've learned three other ways of solving quadratic equations. Remember, a quadratic equation has the form f of x equals ax squared plus bx plus c, or we could say y equals ax squared plus bx plus c. F of x and y, they mean the same thing, right? So our essential question today is, how do you solve quadratic equations using the quadratic formula? The quadratic formula. Remember, there are many ways of solving quadratics. We're not even going to learn about them all. I just picked out the four most important. So today we are learning about the quadratic formula. I will tell you now that I had to have this memorized, and I still have it memorized. It's really, really important. I know some teachers that use Pop Goes the Weasel to memorize it. I personally like Little Bunny Foo Foo. That's just my own thing. So I'm going to teach you the formula. I'm going to sing it for you. Yes, sorry about that. And I'm going to post a YouTube video version of it as well, so you have a couple different ways. Do you have to have it memorized? No, you don't have to have it memorized. But I would encourage you to, because especially when you get to Algebra 2 or any higher math classes, you will need it. So the quadratic formula is a way of getting x by itself. It's a way of solving for x or finding the solution to the equation, right? It's finding the x-intercepts or intercept, depending. It is x equals negative b plus or minus square root b squared minus 4ac divided by 2a. Now, I told you I was going to sing it for you, so here it goes. To Little Bunny Foo Foo. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. I'll do it one more time. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Like I said, have it memorized. It will help you in the long run. Is it very silly? Yes, but it's a great mnemonic device. It's a great way of remembering. So let's do an example together, and I'm going to have you try a couple on your own. We have 2x squared minus 5x plus 3 is equal to 0. We're going to solve it using the quadratic formula. Well, we need to determine first what's our a, what's our b, and what's our c. It's the very first thing we're going to do. So I'm going to color code these, because this is my A, and this is my B. Make sure that you include any positives or negatives with those terms, right? So A is a positive 2, B is a negative 5, and C is a positive 3. So I'm including the positive and negatives from the equation. The next thing I'm going to do is I am going to write down my formula. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. And I'm just going to color code. Everywhere I see an A, I'm marking it with red. Everywhere I see a C, I'm marking it with green. And everywhere I see a B, I'm using my yellow. Didn't mean to use stoplight colors, it just kind of happened. So now our next step is plugging in our values everywhere. Always plug in with parentheses, all right? Plug in using parentheses. Give it a hug. Everyone loves hugs. So we have negative 5 for our b, plus or minus square root, negative 5 squared minus 4 times 2 times 3 divided by 2 times 2. So I plugged in 2 everywhere I saw an A. I plugged in 3 everywhere I saw a C. And I plugged in negative 5 everywhere I saw a B. I'm going to simplify this as much as I can before I start addressing this plus or minus. All right, so let's do PEMDAS and just get everything as simple as we can. Well, we know that a negative 5 is really a positive. Then we've got plus or minus square root. Negative 5 squared is going to be 25 minus. Well, 3 times 2 is 6. 6 times 4 is 24. And I need to divide that by 2 times 2, which is 4. All right, I think we can simplify inside our square root here a little bit more. So we can now have x equals 5 plus or minus 25 minus 24 is the square root of 1 over 4. Well, wait a second. I know that the square root of 1 can be simplified even more, because that's really just plus or minus 1 divided by 4. Remember, every square root always has a positive and negative option, right? It always has two answers. So that's why I have this plus or minus here. So now let's take the two different versions. Let's say that we have the what if x is, or 5 plus 1 over 4. Well, then we'd have 5 plus 1 is 6. So we'd have x equals 6/4. Hey, wait a second. I can reduce that fraction down. So this is really x equals 3/2 or 1.5. I personally prefer the fraction. That was the what if it's the add. Let's see if it's the what if it's the subtract. X equals 5 minus 1 divided by 4. Well, 5 minus 1 is really 4 divided by 4. Hey, wait a second. 4 divided by 4 is 1. So our two answers are x equals 3/2 and x equals 1. Those are our two answers. So now I want you to practice. All right, I want you to practice. So turn the page over. There are two problems on here. The first one is x squared minus 6x plus 5 equals 0. Use the quadratic equation to solve it. The next one is this 4x squared minus 4x equals negative 1. You're going to have to solve this, right? Because we have to have it equal to 0. So pause the video right here. Try these out. All right, this is what you should have gotten. We have an a equals 1, b equals negative 6, and c equals 5. So when I go to plug that in, I get x equals negative 6, plus or minus the square root of negative 6 squared minus 4 times 1 times 5 divided by 2 times 1. So when I simplify that down, we get a positive 6 plus or minus 36 minus 20, the square root of, then divided by 2. The square root of, or 36 minus 20 gets us 16. The square root of 16 is 4. So if we add 6 and 4, we get 10, and 10 divided by 2 is 5. If we subtract 6 and 4, we get 2. 2 divided by 2 is 1. So your two answers are x equals 5 and x equals 1. Let's check out our second one. First, we had to solve this, get it equal to 0. So I had to add 1 on both sides. Then I could identify my a as 4, my b as negative 4, and my c as 1. When I plug that in, I should get positive 4 plus or minus the square root of 16 minus 16 divided by 8. Well, wait a second. 16 minus 16 is just 0. So if I have 4 plus 0, I get 4. And if I have 4 minus 0, I get 4. That means there's only one answer for this question. So we have x equals 4/8, which is the same thing as x equals 1/2. Excuse me. So hopefully we're feeling pretty good about plugging in and solving using the quadratic formula. Hopefully we're feeling pretty good about solving using the quadratic formula. Let's take a look at a word problem. Ooh, I know, right? So for this next one, the number y of Northern Rocky Mountain wolf breeding pairs, x years since 1990, can be modeled by the function y equals 0.2x squared plus 1.8x minus 3. When were there about 35 breeding pairs? 35 breeding pairs. Breathing pairs. Silly. So we know that y is the number of breeding pairs, right? The number y of wolf breeding pairs. And then x is our years. X is our years since 1990. So I want to figure out when I had 35 for my y. So we've got y equals 0.20x squared plus 1.8x minus 3. So I need to plug in 35 for my y. So now I have 35 equals 0.20 x squared plus 1.8x minus 3. It's asking me to find x. I need to find x. Well, I'm going to use the quadratic formula to solve this. First, I need to move my 35 over. So I'm going to subtract it from both sides because then I get a nice 0 equals 0.20 x squared plus 1.8x minus 38. Now I can solve this. And I know that I have an a of 0.20. My b is 1.8 and c is negative 38. And I'm just going to color code this again because colors really help my brain. They really do. The quadratic formula is x equals negative b plus or minus square root b squared minus 4ac divided by 2a. So I'm going to plug in what I know. I know that my b is 1.8, so I have negative parentheses 1.8 plus or minus the square root of 1.8 squared minus 4. My a is 0.2. My c is negative 38. And then I need to divide that by 2 times 0.2. So let's simplify. Well, negative 1.8 is just a negative 1.8 plus or minus the square root of 1.8 squared gets me 3.24. I'm going to round it, all right, 3.24. Plus, because I have a negative times a negative, I get a positive. 4 times 0.2 times 38 gets us a lovely 30.4. So now, and then 2 times 0.2 gets us a 0.4 in our denominator. So now I can actually combine inside my radical here, and we get x equals negative 1.8 plus or minus the square root of 33.64 divided by 0.4. This is where you really have to have a calculator, right? You have to. There's no other way to do this because I have no idea what the square root of 33.64 is. Not off the top of my head. So we should get x equals negative 1.8 plus or minus. The square root of 33.64 should be about 5.8 divided by 0.4. Now we can play the what if game. Well, what if we add those? So what if we have x equals negative 1.8 plus 5.8 divided by 0.4? That's our first what if, right? Negative 1.8 plus 5.8 gets us an x equals 4.0 over 0.4. And that would be 4 divided by 0.4 is 10. So that's if we added. Let's do the what if we subtracted. So then we'd have x equals negative 1.8 minus 5.8 divided by 0.4. They're both negatives, so we get x equals negative 7.6 divided by 0.4. So we would have an x equals, you actually get negative 19 because positive and negative make a negative when you divide, and then 7.6 divided by 0.4 is 19. So let's think about these. This is the algebra answer, right? But which one actually makes sense? Let's move back up to our graph and look. Does it make sense to have a negative 19 that's somewhere over here? Or does it make sense to have a positive 10 that's over here? Which makes sense? So our real world answer should be 10 years after 1990. So that would be in 2000. We were looking for 35 breeding pairs. Of wolves. There we go. So you have to think about what answer you get and what really makes sense. All right? You have to think about what answer you get and what really makes sense for that situation. All right, let's take a look at what we call the discriminant, which is part of our quadratic function here. Okay, it's part of it. And it's a very important part. And again, when you get to Algebra 2, uber important. You're going to learn all about discriminants. They're probably going to be your best friend, truth be told. So let's flip this page over. We have right here options for some of what our quadratics look like, right? Now, remember, we can have upward opening quadratics or downward. But it doesn't matter if they open upward or downward. They're either going to have two real solutions. So they cross the x-axis twice. They have two x-intercepts, excuse me. Or they have one real solution. They just touch it once, right? They just touch it once, and that's where their vertex is. We've seen that a lot. So they only have one x-intercept. Or they don't touch it at all. And I told you that when you get to Algebra 2, you'll go into more detail as to when this happens and how we can find solutions. We just say that there's no real solutions, right? They have no x-intercepts, no real x-intercepts, so they have no solution. The discriminant is what determines all of this, all right? So the discriminant is that part that's inside the square root. So it's the b squared minus 4ac. This is the discriminant. This is the discriminant. Highlight it on your paper, make it stand out. This is the discriminant. When it is greater than 0, when this guy is greater than 0, there are two solutions. All right? When the discriminant is equal to 0, when it's equal to 0, there's one solution. And then if it's less than 0, there are no real solutions. So all we're going to do is focus on the discriminant. We're not actually going to solve for x with these next three. We are just going to use the discriminant. So I'm going to write down b squared minus 4ac. For our first one here, we have an a of 3, a b of 10, and a c of 2. So I'm going to plug in 10 squared with my parentheses, minus 4. A is 3, and C is 2. And I just want to see what this equals. Well, 10 squared is 100. And then I need to subtract. 4 times 3 is 12, times 2 is 24. So we get 76. We get 76. Is this bigger than 0, equal to 0, or less than 0? 76 is greater than 0. So there are how many solutions? Two real solutions. All right, that's all we're doing. I want you to pause the video, try the next two, see what you get. All right, you should have gotten that our middle one here was 36 minus 36, which equals 0. So there's one real solution. There's only one answer for the middle one. And then our far right one here, you should have gotten 1 minus 4, which is a negative 3. Because it's negative, there's no real solutions. No real solutions, all right? And you will find out more about that, like I said, in Algebra 2. For the next part of this video, I want you to just practice using all 4 methods, all right? Practice using all 4 methods. So we are going to start with these two problems. X squared minus 10x equals 1. And then our next one is 2x squared minus 13x minus 24. You're just practicing. Pick any method. I do not care which of the 4 that we have learned that you use. All right, with this first one, I actually solved this. So I subtracted 1 on both sides, and I got x squared minus 10x minus 1 equals 0. And then I chose to do quadratic formula. I'm just a fan of the quadratic formula in general. So my a was 1, my b was negative 10, my c was negative 1. So when I plugged that in, I got x equals negative 10 plus or minus the square root of negative 10 squared minus 4 times 1 times negative 1 divided by 2 times 1. You should have gotten, when you did this, x equals 10.0990. Remember, go with 4 decimal places. And x equals negative 0.0990. Let's scooch the paper up and we'll take a look at the next one. So for this one, this is factorable. All right, it doesn't matter which way you picked. It doesn't matter which way you picked. I decided to factor it, but if you plugged into the quadratic equation, cool. We should have the same answers. So I factored this and got 2x plus 3 times x minus 8 equals 0. And then I looked at each of these separately. So if 2x plus 3 was the 0, then I would subtract 3 on both sides. 2x equals negative 3, divide by 2. So I would get x equals negative 3/2 for my first answer. For this one, if it was x minus 8 equals 0, I'd add 8 on both sides, and I would get x equals 8. So those should be the two answers you have. X equals negative 3/2 or negative 1.5, and x equals 8. Let's check out 2 more problems. So for our top one, we have x squared plus 8x plus 12 equals 0, and for the bottom one, we have x squared plus 11x minus 12 equals 0. Pause the video here, try these out. All right, for the top one, I chose to factor it again. So I got x plus 2 times x plus 6. I set x plus 2 equal to 0, got x equals negative 2. I set the x plus 6 equals to 0. I subtracted 6 on both sides and got x equals negative 6. I also factored for the bottom one. So with that one, I got x plus 12 times x minus 1. Your two answers should be x equals negative 12 and x equals 1. Again, it does not matter which method you chose as long as you got the same answers. All right, let's take a look at 2 more. So our next 2, we have 9x squared minus 5 equals 4, and 5x squared minus x minus 1 equals 0. Those are our next 2. All right, with the top one, because this was just an x squared, I chose to use square roots to solve it. So I added 5 on both sides. So I got 9x squared equals 9, divided by 9 on both sides, get my x squared by itself. So 9 divided by 9 is 1. And then when I square root, I get x equals plus 1 or x equals negative 1. So those are my 2 answers, x equals positive 1, x equals negative 1. And then for the last one, like I said, I'm a fan of the quadratic equation, so I chose to plug it in, mostly because I couldn't factor it, and I didn't just have an x squared. So it kind of ruled out the other methods we've learned, right? So quadratic formula was the way to go for me, personally. When you do this, you should have gotten x equals negative 0.3582 and x equals 0.5582. Those were the 2 answers I got. There's one more video we're going to do with this chapter, and it's just going to be going over all the different methods we've learned and kind of comparing and contrasting when might you use them. Skills practice is posted. Try it out.